Would you please introduce yourself and explain the engineering field you are a part of?
Sure, I'm Dr. Jim Maloney, and I am a materials scientist or materials engineer.
Can you explain how this career has changed and developed throughout the time you have been a part of it?
Um, yeah, that's actually a very good question. I think that the profession has changed in the sense that we have developed a lot more knowledge than we had before. And one of the biggest things that has changed is the advent of using finite element analysis for stresses and strains, and also using modeling of thermodynamic systems, which actually help us design alloys and understand materials. So computers have made a tremendous change in the way we actually educate ourselves and the way we do our jobs.
Okay, awesome. What devices and programs do you use in this type of engineering field?
Well, we do everything from what we call mechanical testing, which is hydraulic machines that pull tensile samples of steel or other metals to determine how strong they are, to full-scale models and parts testing so that we can find out how things will react to real-world stresses and strains. Um, and we also then use the computers, as I talked about, and we use a lot of programs like ThermoCalc, which is a thermodynamics program. We also use a program called Stress, which does stresses and strains. So we have a lot of computer tools. We have old-fashioned mechanical tools, and of course we use the pencil and paper tools and calculators.
What type of educational path would you recommend for people interested in this career?
Well, if you want to be a materials scientist, you most likely would want to do pretty well in math and science through high school, and you would like to then go to an engineering school and get a bachelor's degree in an engineering discipline. In my case, that was materials science or materials engineering, and that would be taught at many universities throughout the country and many state schools also.
And have you heard of any special programs?
We actually do a lot of outreach in various nations throughout the country between the Society of Metallurgical Engineers, which is there's two of them actually. One's called the Metallurgical Society and one's called the American Society for Materials. And there's a lot of outreach to students to um, have them shadow engineers for a day or go to Metals Park, Ohio and take classes and do experiments. So there are a number of opportunities to get involved with the materials world.
Okay, and can you explain a day-to-day life in your part of engineering?
Sure. I do an awful lot of work with suppliers who supply materials. I work in the aerospace industry. So they supply the materials that we use to make bearings for landing wheels and jet engines and things like that. And one of the things I do is work with the suppliers to make sure that they properly manufacture the material that we are going to use to make bearings. So there are specifications and audits of the suppliers to make sure that things are going correctly. And then once we get it in-house, we actually do a thing called heat treating, where we develop the mechanical properties of that material. And that is done in furnaces with quenching and tempering and deep freezes. And we specify that, measure the properties, and tally the data so that we are sure that we're making good product so that when you fly, you're safe.
Okay, and what would you say is the most exciting or interesting part of your career?
Oh boy, that's a very good question also. I've always enjoyed alloy development, but I also enjoy the heat treating part of it, developing mechanical properties that are useful to people. So, for example, what we do an awful lot of is bearing gears. Again, mostly I work in the aerospace end of it. So we are doing bearings and gears that allow people to fly and have mobility. So it's really exciting to be able to take. Basically, you start off with steel; it's scrap. That's the stuff you put in your recycle bins. We take that material, melt it, make a special alloy composition, and heat treat it, and then make a product that enables people to go around the world.
All right, well, thank you very much for your time.
Thank you.
You're welcome.